In this video, we will take a look at a general case example of matrix multiplication. So there are some rules that we need to follow in order to multiply two matrices. And the rule is that if you are trying to multiply matrix A with matrix B, the number of columns in matrix A need to match the number of rows in matrix B. As long as this condition is satisfied, we will be able to multiply the two matrices A and B. So assuming that this rule is satisfied, let's take a look at two matrices, matrix A and matrix B. Let's choose the size, also called as the order or dimension of matrix A, as n by m. N over here is the number of rows in matrix A, and m is the number of columns in matrix A. And just so that we satisfy the condition, we will choose the number of rows in matrix B to be m as well. And k is the number of columns in matrix B. Now, when we do multiply A and B, let's say our resulting matrix is called Z, and Z will have the size of n by k, where n is again the number of rows and k is the number of columns in the resulting matrix Z. Let's take a look at some general matrices. Over here I've laid out matrix A with several elements in matrix A. I'm denoting the size of matrix A as n rows and m columns. And similarly for matrix B, I have all the elements that go into matrix B. These could be constants, these could be variables, but the size of matrix B is m by k. So the inner values of the size match, m over here and m over here. And if we do multiply A and B, our resulting matrix, we are going to fill this up in just a bit, is going to have n rows and k columns. So the resulting matrix is going to be an n by k matrix. Now, how do we multiply two matrices? The way we do that is by first taking, say, the first row of matrix A and multiplying that with the first column in matrix B to get our first element in the result. So I'm going to take, and I'm going to be doing a dot product or the elements wise product between the first row of A with the first column of B in order to get one element in the resulting matrix Z. So the first element is going to be A11 multiplied by B11 plus A12 multiplied by B21 plus so on up till A1M multiplied by BM1. Now, just for the sake of convenience, we can rewrite all of this summation in a very compact manner as, say, a parameter I going from 1 to capital M, and if you can notice here, it goes A11, 12, 1M. So to fill in the summation, I'm going to get 1A, 1I multiplied by BI1. So that's my first element. I hope you noticed that the way I've chosen these numbers, these subscripts, 1, 1, is because this is the first row, first column element. First row, second column element in A. First row, mth column in matrix A. For example, this element, nth row, second column in matrix A. Nth row, mth column element in matrix A, and so on. I've done that the same thing for matrix B as well. So now coming back to our resulting matrix, I can erase all of this summation which I wrote in long form and just replace this with that particular summation. That's my first element. Now, in order for me to find out the second element, or first row second column element in the resulting matrix, I need to take the same first row of A and find the dot product between the first row of A and the second column of B. So now I'm going to be doing, I'm just going to move this over here. To get my second element. And if I do the same thing right in compact fashion, then I can write that as A1I BI2, because all that changes is the column in B is numbered 2. Earlier it was numbered 1. So I get my second element straight away. And then I fill up this matrix. Let me just find out the last value in row 1, which is going to be the first row of A multiplied by the last column of B. And this again can be written in compact manner using a summation sign as I going from 1 to M, A1I multiplied by BIK. All right, next let's move on to row 2 of the resulting matrix. So for me to move to row 2, I'm going to move back to the first column of B, but I'm going to now consider the second row of A to fill up my second row first column. So it's going to be very similar to this element. So let me just copy and paste this and then change accordingly. So my second element is now having A with subscript of 21, 22, 2M. So all I need to change is the row number to A2I. And then because this is the first element of B's, BI1 remains as is. And I need to do that M times. Similarly, I move to the second one, and I hope you get the pattern here. We can go quickly, paste it over here, and then this changes to 2. Similarly, I had the last value here. Instead of 1, I'm going to get 2. And I need to do that for all these elements. So let me write the last row of the resulting matrix. I'm going to get the last row of resulting matrix by taking the last row of A and multiplying by all the columns in B. So if I do that for the first element, this is going to have ANI, because I'm multiplying AN1 with B11, AN2 with B21, AN3 with B31, all the way to ANM with BM1. All of those are being captured by this summation. And then my second element here in the last row is going to be ANI BI2, and of course all the way to the end going to be I from 1 to M. I have A, N, I, B, I, K, which is AN1 multiplied with, so we have AN1 B1K plus AN2 B2K plus and so on up till ANM multiplied by BMK. All of those summations are being captured by this particular sign. And I'm just writing this as a general form, so I'm going to write some dots to show that it is a pattern. So we've got this resulting matrix in which we have written up first row first column element, first row second column element, first row last column element. So we have got 1, 2, K columns, 1, 2, N rows. So our resulting matrix is N by K. All right, I hope this general case example was helpful. See you in the next video.